Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on the hydrolysis of salts. In our last lesson, we defined salt hydrolysis as the reaction of an anion or a cation of a salt, or both, with water. We discussed that the nature of the solution of salts depends upon the strength of the parent acids and bases. We learned that the hydrolysis of salts of strong acids and strong bases form neutral solutions. We also learned that the hydrolysis of salts of weak acids and strong bases produce basic solutions. In today's lesson, we will explain why a salt of a strong acid and a weak base gives an acidic solution. We will also discuss why a salt of a weak acid and a weak base produces either an acidic, basic, or a neutral solution. We will look at the nature of the solutions of different types of salts. Let us get started. A cation, which is the conjugate acid of a weak base, hydrolyzes as an acid. Due to this, the anions of a strong acid are weak conjugate bases that do not hydrolyze. Students, please consider ammonium sulfate. It is the salt of ammonia, which is a weak base, and sulfuric acid, which is a strong acid. What is the ion that can be hydrolyzed from ammonium sulfate, and what is the nature of the solution of this salt? Think about these questions and then write your answers on a piece of paper. We will discuss them in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hi, everyone. It is nice to see you again. Ammonium sulfate ionizes in aqueous solution into ammonium ions and sulfate ions. However, the ammonium ion is a conjugate acid of a weak base, and it hydrolyzes to a greater extent. The solution that is formed is acidic. The hydrolysis reaction looks like this. As you can see, ammonia and hydronium ions are produced. Let us move on with our lesson by discussing the hydrolysis of salts of weak acids and weak bases. We will begin this portion of our lesson with an activity. You will compare the acid dissociation constant and the base dissociation constant values of anions and cations. This will show you the nature of the solution of the salts we are going to consider. Students, in a moment you will see a table. Use this table to determine whether the solutions of ammonium fluoride, ammonium thiocyanate, and ammonium acetate are acidic, basic, or neutral.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I hope you did not find this activity to be too difficult. You may have noticed that if the acid dissociation constant is greater than the base dissociation constant values, then the salt is acidic. If the base dissociation constant values are larger than those of the acid dissociation constant, the salt solution is basic. If the acid dissociation constant and the base dissociation constant are equal, then the salt solution is neutral. According to this logic, the ammonium fluoride solution is acidic. The ammonium thiocyanate solution is basic, and the ammonium acetate solution is neutral. The solutions of ammonium fluoride, ammonium thiocyanate, and ammonium acetate contain both a strong acid, which is the cation of the weak base, and a strong base, which is the anion of the weak acid. The relative strengths of the acidic cation and the basic anion determine the nature of the solution of this type of salt. If the acid is stronger than the base, then the solution will be acidic. However, if the base is stronger than the acid, the solution will be basic. If they are of equal strength, the solution will be neutral. Students, as a summary of everything we have learned about the hydrolysis of salts, let us work together to create a concept map. At the very top of this map, we place the word hydrolysis, as this is the topic of our concept map. In the 4 branches that come off of the word hydrolysis, we place the types of hydrolysis that can occur. This includes salt derived from a strong acid and a strong base, salt that has a weak acid and a strong base, salt derived from a strong acid and a strong base, and salt that has a weak acid and a weak base. The branch that comes off of number 2 is labeled neutral solution to represent the nature of the solution of this type of salt. In turn, the branch off of number 3 is basic solution. The branch off of number 4 is acidic solution. And the 3 branches off of number 5 are neutral, basic, and acidic. This is because the nature of this type of salt can be any of these. In today's lesson, we discussed the hydrolysis of salts of strong acids and weak bases, and the hydrolysis of salts of weak acids and weak bases. We learned about the nature of the solutions of different salts. This brings us to the end of our lesson for today. In our next lesson, we will be learning about acid-base indicators. Until next time, thank you, teacher, and thank you, students.